Hello students, let's solve some more examples on system of linear congruences. Example, find the least positive integer such that integer x such that first x congruents to 5 modulo 7, x congruents to 7 modulo 11, x congruents to 3 modulo 13. Second, x congruents to 1 modulo 3, x congruents to 1 modulo 5, x congruents to 1 modulo 7. Now, solution. First, given system is x congruents to 5 modulo 7, x congruents to 7 modulo 11, x congruents to 3 modulo 13. So here let a1 is how much? 5, a2 is 7, a3 is 3. Small n1 is 7, n2 is 11 and n3 is 13. Again here this n1 n2 that is 7 11, n2 n3 that is 11 13 and n1 n3 that is 7 13 are relatively prime. Therefore we can use Chinese remainder theorem to find this simultaneous solution. So let this capital N1 is how much? N2 N3, it is 11 into 13, that is 143. N2 is N1 N3, it is 91 and N3 is N1 N2, it is 77. Now consider Nix congruents to 1 modulo Ni for all I from 1, 2 and 3. Therefore, N1x congruents to 1 modulo N1 gives 143x congruents to 1 modulo 7 has solution. I got it. X1 is what? 5. I try for 1, 2, 3 and so on. I got it as 5. Again N2x congruents to 1 modulo N2, that is 91x congruents to 1 modulo 11 has solution x2 as 4. Fine. Then N3x congruents to 1 modulo N3, it gives us 77x congruents to 1 modulo 13. Now has a solution x3 as minus 1. It will become minus 77 minus 1, so minus 78. So that will be, it is divisible by 30. Fine. So x3 is equal to what? Minus 1. Then if this is, then x bar a1 x1 n1 plus a2 x2 n2 plus a3 x3 n3 modulo n1 n2 n3. So it gives us a1 is 5 into 5 into 143 plus 7 into 4 into 91 plus 3 into minus 1 into 77 modulo 7 into 11 into 13. It is 1001. So it congruents to, this is 3575 plus 2548 minus 231 modulo 1001. So it is 5892 modulo 1001. So modulo 1001, here the remainder is 887 modulo 1001. So this gives x bar is this. So we get 1001 divides x bar minus 887. That is x bar equal to 887 plus 1001 k for k in z. So these are various solutions, and here the least positive integer is how much? 887. So this shows that x equal to 887 is the least positive integer satisfying the given system. Okay, now let's solve the second system. Second, the given system is x congruents to 1 modulo 3, x congruents to 1 modulo 5 and x congruents to 1 modulo 7. So let a1 is 1, a2 is 1 and a3 is also 1. n1 is 3, n2 is 5 and n3 is 7. Here the pairs 3 5, 5 7 and 3 7 are relatively prime. So we can easily apply the Chinese remainder theorem. So let n1 is n2 n3, it is 35. n2 is n1 n3, it is 21. And n3, that is n1 n2, it is 15. So consider the congruences. Nix congruents to 1 modulo ni for all I from 1, 2 and 3. So n1x congruents to 1 modulo n1 gives 35x congruents to 1 modulo 3. So If we put x equal to 1 here, 35 doesn't congruence to 1 modulo 3. 35 congruence to 2 modulo 3. Fine. So if we put x equal to 2 here, so it will become 70. 70 congruence to 1 modulo 3. So solution x1 equal to how much? 2. Again, n2x congruence to 1 modulo n2. This gives 21x congruence to 1 modulo 5. Has solution x2 equal to how much? 1. Has solution x2 equal to 1. And n3x congruence to 1 modulo n3. It gives us 15x congruence to 1 modulo 7. It also has a solution 1. Has solution x3 equal to how much? 1. Then what is x bar? X bar congruence to a1 x1 n1 plus a2 x2 n2 plus a3 x3 n3 modulo n1 n2 n3. So what this is? This is 1 into 2 into 35 plus 1 into 21 plus 1 into 15 modulo n1 n2 n3. So 15 sevens, so it is 105. Okay, so this is 70 plus 21 plus 15 modulo 105. So this is congruence to 100. This is 106 modulo 105. So we get the remainder is how much? 1 here modulo 105. Okay. So x bar congruence to 1 modulo 105. So x is equivalent to whom? 1 here, as 105 divides x minus 1. That gives us x equal to 1 plus 105k for k in z. If k equal to 1, then x equal to how much? 106. And if k equal to minus 1, x equal to minus 104. Therefore, least value of x is 106, which satisfies the given system. Now let's go towards the next example. Check whether the following system is solvable. If S, find all solutions. So first, x congruence to 29 modulo 52, x congruence to 19 modulo 72. Second, 5x congruence to 1 modulo 6 and 4x congruence to 13 modulo 15. So solution, let's check are these solvable or not. First one, given system is x congruence to 29 modulo 52. Call it as question number 1. X congruence to 19 modulo 72. Now here we cannot apply Chinese remainder theorem directly, so we cannot say about is it solvable or not. Why does this? As this 52 and 72 are not relatively prime to each other. So let's convert this system into a new system. So how does that? Let's see that. Here this 52 can be written as 4 into 13, and this 4 and 13 are what? Relatively prime. Therefore, equation 1 is equivalent to x congruence to 29 modulo 4 and x congruence to 29 modulo 13. That is x congruence to 1 modulo 4, call it as equation number 3, and x congruence to 3 modulo 13. It is equation number 4, suppose. Okay. Also 72. This 72 can be written as 8 into 9, and this 8 and 9 are relatively prime. Therefore, equation 2 is equivalent to what? X congruence to 19 modulo 8 and x congruence to 19 modulo 9. Okay, that is, what can we say? X congruence to 3 modulo 8. Call it as equation number 5, and x congruence to 1 modulo 9. Okay, call it as equation number 6. Now this, from 1 we get this 3, 4, and from 2 we get this 5, 6. So let's take them togetherly. That will be nothing but our given system. Therefore the given system is equivalent to what? This x congruence to 1 modulo 4, x congruence to 3 modulo 13, x congruence to 3 modulo 8, and x congruence to 1 modulo 9. Okay. Now here this x congruence to 3 modulo 8, x congruence to 3 modulo 8, it gives us 8 divides x minus 3, that is x equal to 3 plus 8k. For k in set of integer, that is x equal to 3 plus 4 into what? 2k for k in z. That is x equal to 3 plus 4k dash I can write, where k dash is what? Even multiple of k. Fine. Here this also belongs to what? Set of integer. Fine. So what does this give? This gives 4 divides x minus 3. That is x congruence to 3 modulo 4. Means this x congruence to 3 modulo 8 can be written as x congruence to 3 modulo 4. Okay. That is x congruence to 3 modulo 8 is equivalent to x congruence to 3 modulo 4. Therefore, we get the system, or we have a system. Again this system will change due to that. So this is first equation, x congruence to 1 modulo 4. Then x congruence to 3 modulo 13. Next x congruence to 3 modulo 4. And x congruence to 1 modulo 9. But here these two equations gives a contradiction. Here modulo 4 will give us a remainder 1 as well as 3. This is not possible. That's why this system doesn't have a simultaneous solution. So here we will write that part. But the equations are the congruence equations. The congruence equations x congruence to 1 modulo 4 and x congruence to 3 modulo 4 shows that an integer x gives the remainder 1 and 3 when divided by 4, which is impossible. Therefore, the given system has no simultaneous solution. Now let's solve the second one. Second, given system is x congruence to 1 modulo 6 and 4x congruence to 13 modulo 15. Again here this 6 and 15 are not relatively prime, so we are unable to apply Chinese remainder theorem. So convert into a new system, then check whether it is solvable or not. So here this 6 can be written as 2 into 3 and these 2 and 3 are relatively prime. Therefore this 1 is equivalent to, equation 1 is equivalent to 5x congruence to 2 modulo 6. 5x congruence to 1 modulo 2 and 5x congruence to 1 modulo 3. That is, this is can be written as x congruence to 1 modulo 2 and minus x congruence to 1 modulo 3. Since 5u congruence to minus 1 modulo 3. Okay, or that is x congruence to 1 modulo 2 and x congruence to minus 1 modulo 3. This is equation number 3 and this is equation number 4, suppose. Fine. Also, this 15 can be written as 3 into 5 and this 3 and 5 are relatively prime. Therefore, equation 2 is equivalent to 4x congruence to 13 modulo 3 and 4x congruence to 13 modulo 5. That is x congruence to 1 modulo 3 and minus x congruence to 3 modulo 5. Or that is x congruence to 1 modulo 3, call it as equation number 5, and x congruence to minus 3 modulo 5. It is equation number 6. Therefore, the given system is equivalent to x congruence to 1 modulo 2, x congruence to minus 1 modulo 3, or x congruence to 2 modulo 3 also we can write. X congruence to 1, this x congruence to minus 1 modulo 3 can be written as x congruence to 2 modulo 3. Remember this. These are equivalent, or you can say. And this is x congruence to 1 modulo 3, x congruence to minus 3 modulo 5. So from these two things, look at here. Modulo 3, the remainder are 1 and 2. So from x congruence to 2 modulo 3 and x congruence to 1 modulo 3, we can see that an integer x gives the remainder 2 and 1 when divided by 3, which is impossible. Thus, equation 1 and 2 has no simultaneous solution. That is, the given system is not solvable. Okay, now let's see the next example. Find all integer x that gives the remainders 1, 2, 3, 4, 5 when divided by 3, 5, 7, 9, 11 respectively. So solution, let x be such an integer which gives remainder 1, 2, 3, 4, 5 when divided by 3, 5, 7, 9, 11. That is, x congruents to 1 modulo 3, x congruents to 2 modulo 5, x congruents to 3 modulo 7, x congruents to 4 modulo 9 and x congruents to 5 modulo 11. Here x congruents to 4 modulo 9 gives 9 divides x minus 4, that is x equal to 4 plus 9k for k in z, that is x equal to 4 plus 3 into 3k, where 3k in z. So this gives x, or 3 divides x minus 4, that is x congruents to 4 modulo 3. Now this is equivalent to x congruents to 1 modulo 3. So x congruents to 4 modulo 9 is equivalent to x congruents to 1 modulo 3. Therefore, the given system becomes x congruents to 1 modulo 3, x congruents to 2 modulo 5, x congruents to 3 modulo 7. Now no need to write this fourth equation, that is x congruents to 4 modulo 9. This is equivalent to this first one. That's why we write one of them only. And the last one, x congruents to 5 modulo 11. Fine. Now here here A1 equal to 1, A2 equal to 2, A3 equal to 3, A4 equal to 5. N1 is 3, N2 is 5, N3 is 7, N4 is 11. And 3, 5, 5, 7, 7, 11 and 3, 11 are relatively prime. Also, let what is N1? N1 is N2, N3, N4, that is 385. What is N2? N2 is N1, N3, N4, that is 231. N3 is N1, N2, N4, that is 165. N4 is N1, N2, N3, that is 105. Okay. Now here consider NIX congruence to 1 modulo NI for I from 1, 2, 3 and 4. Okay. So N1x congruence to 1 modulo N1 gives 385x congruence to 1 modulo 3 has solution x1 equal to 1. Again N2x congruence to 1 modulo N2 gives 231 x congruence to 1 modulo 5 has a solution x2 equal to 1. N3x congruence to 1 modulo N3 gives 165x congruence to 1 modulo 7 has solution x3 equal to 2. And N4x congruence to 1 modulo N4, that is 105 congruence to 105x congruence to 1 modulo 11 has solution x4 equal to 2. Okay. So consider x bar congruence to a1 x1 n1 plus a2 x2 n2 plus a3 x3 n3 plus a4 x4 n4 modulo n1 n2 n3 n4. So it is equivalent to 1 into 1 into 385 plus 2 into 1 into 231 plus 3 into 2 into 165 plus 5 into 2 into 105 modulo n1, n2, n3, n4. The product will be 1155. Okay. So this is congruence to what? 385 plus 462 plus 990 plus 1050 modulo 1155. So congruence to 2887 modulo 1155. So it congruence to 577 modulo 1155. So x bar congruence to this part. Therefore 1155 divides x minus 577. So this gives x equal to 577 plus 1155 times k. These are various solutions for this, and this k belongs to what set of integer. These are the solutions here. So these are all x satisfying this system of linear congruences. Now here we will stop. In next video we will start the next chapter. Now before going towards that, let me give one example as a homework to you. You have to solve that one either using linear congruence or using the Chinese remainder theorem. Let me give a hint to you for solving it using a Chinese remainder theorem also. Okay. The example says 57x congruence to 87 modulo 105. So here, if you have to apply a Chinese remainder theorem here, this 105 can be written as 7 into 5 into 3, and this 7 5 5 3 and this 7 3 are what? Relatively prime. You have to solve this. This is a homework to you. Okay, and this is a hint. Here this 105 I had written as such. So if you will write this system of this equation as 57x congruence to 87 modulo 7, then 57x congruence to 87 modulo 5 and 57x congruence to 87 modulo 3. So this will be the system. This is a single congruence and this will become a system of linear congruences. So you can solve this system of linear congruences for finding the simultaneous solution for this one. Okay. So here the second chapter is over. Now in next video we will start our chapter 3, that is functions of number theory. Thank you.